for 2026 by the NASCOM. So NASCOM, as you all know, is a national global agency which is enabling uh, all these statistics, and all it's collecting all the data worldwide, and not only in India but also worldwide. So NASCOM is a certified agency that is giving this figure. So second thing here we are talking about is use cases the uh, for the smart city and for the healthcare. So both we have to consider simultaneously here. So now I'm talking about the examples where we are getting the data from. So the very first pointer is wearable vitals tracking. So as you all know, if I am wearing a smartwatch, or if I am wearing a wearable which gives me certain data, or it tracks certain data. For example, if it is giving me my heartbeat count, if it so there would be a normal range of 70 to 90 or 100, whatever is the range of normal heartbeat. It ranges differently in male and female. So there would be some range depending on whatever activity you are doing. So there would be an ideal range. Okay, so this is one of the example wearable vitals tracking. So this is happening from your end, like you are wearing a watch or you are tracking it on your smartphone. So this is one. Second example is smart ICU and remote monitoring. So uh, in advanced hospitals, or the hospitals which have advanced services, there are now this the introduction of smart ICU and remote monitoring. So as you all know, that ICU is the intensive care unit where stringent monitoring is required for the patients with critical, or which are in need of critical care. So they are monitoring it 24/7, or there is someone in the shift, or there is someone on the desk available 24/7 for ICUs. So they have to monitor it manually as of now. Uh, for the ones which are the smart ICUs, or which are already equipped with smart systems, they they will be now enhanced, and they will be equipped with big monitors where they'll be getting data from each bed. As you all know that our like in India we are having many hospitals, and we are not having private ICUs. We There are private ICUs, but in general, we are having around, say, 20 beds per ICU room or per ICU hall. Okay, so for the 20 beds, there will be 20 tracking devices, and maybe like oximeter, or maybe oxygen level, or maybe heartbeat, or blood pressure level, whatever is the parameter they have to monitor or they have to check. They will be getting it on the screens, or the centralized screen, and they'll be getting the alert for the same. So smart ICU and remote monitoring. Third one is AI based health predictions. So as I told you in the first example, which is wearable vitals tracking, so you are giving a certain amount of data to any application which is tracking your data, maybe heartbeat, maybe any of the data, okay, which is concerning with your health. So this data is being is fed to the application which is responsible for predicting certain set of diseases. So for example, if you are having like if you're running for continuously for say half an hour or 15 minutes, okay, and the amount, or the this rate at which your heartbeat is increasing, or the rate at which your the way you should breathe, or what we call it as saans phulna, okay, like you are already pumped up with your lungs, and it should happen after a certain interval, or it should happen only after, say, 10 minutes. So if it is happening at the very earliest stage, or if you are not able to walk, or if you're not able to run for say even 5 minutes, so they are having a certain data, and based on that data, which is already fed to the system or the model which you are training, so it will predict certain amount of say X disease or Y disease. This you can happen. Say blood, you can have a diabetic system. You can also have a high blood sugar, or you can also have say you can have a probability of having a cardiac arrest or heart, any of the diseases which is which is related to heart problems. Okay, so this is the third example, which is AI based health predictions. The fourth one is the smart ambulance systems. As you all know, there are many cases where there are like accidents are happening, or there is a need where ambulance needs to be called up ASAP, as soon as possible. So you're, even if you are dialing 108 and or 100, whatever is the code for the health line help in your city, so there would be, a channel. So once you give a call to the centralized health helpline number, it will ask you for the details, where you are, where are you located, what exactly happened, and so on. So sequence on series of questions will be asked, and meanwhile that, like, that is very precious time for any of the patient to get the first response. So that precious time will be lost in that case. So connected ambulance system will be helping you in giving the live location, in giving you the exact, the near, like what we have in Ola and Uber or the Rapido. Like assist you connecting with the nearest like cab, right? So similar to that, the ambulance which are available nearby, or which are already on the way, or like the emergency services, if you are on any highway, so there would be the nearest emergency services or response team. They will get connected, and you will be getting assistance on for ambulance for in that for that purpose. So there are, like, these are a couple of examples which we are now using, and which are already implemented in many places of our country. But these needs to be, spread widely, so that people are aware of it and people are able to use it on time. So I'll move next. um, I'll talk about a little on the market, which is related to your IoT in, like, healthcare and smart cities. So, as you all know, $2.5 billion is the predictions for 2026. This market will gradually grow more by 230, and it's like global. The average growth rate, which is CAGR, is average is 25% per annum until the next 5 years, which is year 2030. Um, Now, as we all are having like Amazon or Flipkart or any of the shopping cart apps, we are like aware of Boat, we are aware of Noise, or we are aware of Bolt. These are very newly set up or new startups which began. They introduced a new generation of watch, or the smart watches, or the wearables, to be exact, which are tracking all sets, all kind of data for us, right? So this the adoption of such kind of wearable devices have increased. May it be app, where whatever company you're using, Samsung, Apple, maybe any of the ones which I took name of. So these are the devices which are trending now, and these are the ones which will help you enable you know getting all the data about yourself, about your body, about your health. So this will also help you in enabling or predicting the diagnosis for your upcoming diseases or upcoming health issues. Okay, and remote diagnostics is one of the way. Like if many of you might have used Practo or any other app which is having the online consultation facilities or video consultation facilities, so they might be like, if you might have used, so you might be aware that there are like they'll ask you certain set of questions. It will be like in form of yes or no, or it will be in form of certain range, like if you're feeling sour, if you're feeling like if you're having that kind of taste in your mouth, if you're seeing a redness or yellowness in your eyes, or if you're feeling dizzy, whatever may be the symptoms. So based on those symptoms, you will be getting diagnostic support from the doctor or the medical officer. So this is one of the things which I wanted everyone to get acquainted with. Uh, Now, the very important part is integrating these variables or integrating this data with the smart city initiatives. Okay, so as you all know, there are about 250 initiatives taken by like the government of India for smart city. Around 246 was the exact number, but now they have increased. I'm not sure about the current figure, but it was earlier 246. So the among that smart city initiatives, one of them was integrating the healthcare facilities, in which three key points were there, which included emergency response routing, like I mentioned, like Ola, Uber is having the data of like real time data of the nearest cab or nearest auto or nearest rickshaw you want to opt for. So there will be a real time data fed in the centralized system for emergency response, which will be having data of the ambulances or the emergency response team. Suppose if you are on any expressway or if you are on any of the highways, so there are nodal points, or there are like after every like certain amount of like certain kilometers you have emergency services set up. So they'll be having they will be giving you the feeding you the feeding the centralized server with the current data. And whenever you are in emergency or whenever you need any emergency services, so on basis on the nearest point, they will be routed or they will be giving you or providing you the support for that purpose. Second thing in smart city initiative is smart hospital beds, and ambulance telemetry. So the thing this happened in COVID. Many of you are aware that there were like the facilities, the hospitals and other medical facilities were not capable of handling all like they were not capable of handling the full occupancy of the hospital. Like the beds were shrinking, the total number of beds were not able to cope up with the number of patients which were in like coming or getting admitted to the hospitals. So there was no tracker earlier, and there was no data that like although the hospitals have the data that they have so many number of beds, but there was not a real time tracker which was giving you that this hospital is having this much occupancy and this hospital is the nearest, and this will be able to help you in more quicker way or in less time. So that also was introduced post COVID. And talking about the ambulance telemetry, so even if like if the request goes like if you take example of Ola and Uber again. So their request will go in the vicinity of say 1 kilometer or 2 kilometer or 3 kilometer, whatever is the range. Uh, that will be in circle. Okay, so within that circle, whatever cab or whatever auto is getting request, they'll be communicated from the requester. Like I am requesting a ride, so I will be communicating that I am in need of a ride. So I have communicated it once. Now it's on the like it's one to many, right? So for the cab or for the auto which has accepted, there will be a retransmission from that auto wala or from that cab wala, which will give status or signal that is the ride is already accepted. So no second person will be accepting the ride for that person. Okay, so same goes for the ambulance. When there is a like request for ambulance services or emergency services, the nearest ambulance which has responded first or which has the shortest time reaching the place of the event or the accident, so they will be sending a communication signal that this service has been reaching to that place or to the accident site. Okay, so this is a kind of telemetry or the like what we call the protocols, where request and response are acknowledged and communicated through the signals or channels. So this is the second thing. The third important point is cloud based adaptive traffic control for patient mobility. So in our city also, like in if I take example of Jabalpur, so Jabalpur has like grown like progressed further in like past 10 years, and you are able to see more four wheelers on the road and more traffic or more congested roads are now visible. But the size of the road, the size of the population have increased, but the size of the road is the same. So we are getting like in traffic jams, we are stuck in many places, many like signals are there, and many places signals are not working, and people are randomly going and not following anything. They're just like creating a mess. So this is one thing which is the cloud-based adaptive traffic control system, where Google Maps or the Apple Maps, which are the two major provider, Google Earth, whatever the source of live real-time traffic data we are taking. So the Google Maps API, I'll take example of Google Maps only. So Google Maps API will be giving you the feed of current traffic, okay, and that you will get the real-time data from Google Maps on the traffic, and basis on that you will have to adopt the path or the nearest hospital you have to rush is basis on that route which will be fed from the Google Maps. So this is very normal thing which many of us might be following or using Google Maps. But since we all are so much acquainted with the roads or with the daily path which we follow to travel to college or travel back from college to home, that we don't usually use the maps, right? So this is important for people, whether you are acquainted with all the roads, all the gullies, all the mohallas of our sheher, of our city. But this is very important point to use that tracking system or to use the Google Maps for the purpose of earliest response to be given to the patient in need. So cloud based, why cloud based is used here is because the data is coming from the cloud. It may be from the Google Cloud, maybe from the Google Earth. So the data is centralized, and you are using the API, application programming interface, to get that data from your the service provider. So here, if I say Google Maps, so Google is the service provider for that API, and which is also cloud-based application, right? So you are getting a real-time data fed on to your mobile devices. So the reason why we are using cloud-based keyword here is because now the on-the-go data are fed directly from the cloud-based applications to your smartphones or smart devices. So that's why the cloud-based adaptive traffic control for the patient mobility. Patient mobility can be like with with ambulance or without ambulance. So for either ways, this integration is required for better response or the earliest response for the patient or for the people needing medical care. Now let's talk a little bit about agentic AI in IoT healthcare. So, if I may ask, like, how many of you are aware with the this keyword agentic AI? So, I would assume like many of you are aware of the keyword agentic AI. But if you're not, I'll just give you a brief introduction about what is in AI. In artificial intelligence, there are many paradigm which are being used for various purposes, and they are serving different purposes. So the one which we are normally using in ChatGPT, in our Copilot, Microsoft Copilot, are the ones which is generative AI. We are giving some prompts to the system, and the prompts, basis on the prompts which we are feeding to the system, we are getting a certain output generated. Okay, so this is what we are generating the output, or we are feeding the data and it's giving us the output. Agentic AI, suppose, like agentic AI is all about an agent which will act uh, like like an agent on behalf of any of us, which is which requires a data to be fetched, or which requires a certain task to be completed. So the AI agent will be in place. Suppose if you want that you want to book a car ticket at 10 a.m. Indian Standard Time for source to destination, say Jabalpur to Mumbai CSMT, and you are providing your IRCTC credentials to that agentic, like the agent, AI agent, and you will be logging to the IRCTC website or the IRCTC mobile app. So you are giving access, all required access, you are giving all required data to that agent, which will be, giving you entire reservation part completed without doing anything. So you are already giving everything, every data, even your login credentials, your password, your source city, your destination, your train number which you want to book. Okay, and if you are boarding from any other station, so you also have to give you the boarding point, and even you have to give your credentials for, say, Paytm or Google Pay or Phone Pay, whatever application you are using for the payment service. So that is kind of the agentic AI example which we will be using. So if everyone is understood about agentic AI, I'll move forward. So can I get a like acknowledgement? Can I get a feedback if everyone is with me till here?
Yes, sir, you may proceed.
Okay. So I'll begin with the example which is for our healthcare and smart cities. So there will be an AI agent. An AI agent will be comprising of your smart devices, your devices which are monitoring patient data in hospitals, say one which are in available in ICU. So oximeters, all your heartbeat, all your ECG data, all other data. So all those data will be fed into a system or into application, and there will be certain sensors. Okay, so AI agent will sense that data based on the sensors, and it will think about the data, okay, which is fed into the application. So as I discussed earlier, there will be certain range based if you are male or female, if your heartbeat is in certain range, if your blood pressure is in certain range, it will be low blood pressure or high blood pressure, whatever is the data. Okay, so the data will be trained for these all the scenarios. The data will be trained, and based on that training set, the system will be thinking and taking a action. So it will sense, it will think, and then it will act. So basis on the data which we have already trained the system, the action will be taken. So what kind of action will be taken? Like there can be an alarm, there can be a signal sent to the monitoring or the people on duty for that ICU unit, or for that for example, if there is a critical patient, so a doctor is appointed for him, or for say 12 hours in his shift, say evening 6 p.m. to morning 6 a.m. So for that 12 hours, the signal will be sent to that doctor on and the nurse in charge for that particular time interval. So this is the action. So our action are very limited, because still healthcare industry or the health, the real time action is more important than the signals which we receive. So the late action taken is very dangerous for any of the patient's life. So to coop up, or to this is a drawback in medical system. Okay, so to reduce that time, response time, what we call MTTR, mean time to provide the response for any of the triage, or any of the this request received in that sense. So this needs to be automated through the triage response system. So the second point I'm coming to is automate triage responses. So if I have triggered any alarm, say if in our college there is any of the classroom is having any fire, so the fire sprinkler should automatically trigger the like water, or the sprinklers should be automatically activated in that classroom without waiting for any like manual effort or manual intervention to be, to come and see if the fire was actually there or not. Okay, so automated triage response is required in that particular at that particular point to give the faster, quicker response. Okay, the third point is predictive recovery analytics. So predictive recovery analytics is same as, like, if you're not drinking water, or say, like, example, if you should drink 4 liter of water every day, and if you're not drinking that, you might be having dry skin, you might be having you might not be able to do your morning activities in like very smoother, quicker manner. Okay, you might be having some congestion in your stomach. Okay, so you might be facing some common things which are cause of not having a certain amount of water every day, right? So it's because of shortage of water in your body, dry skin or dryness, or whatever. Okay, so prediction based on the data or the analytics, which which will help you to recover. So there would be an alarm which will be set every half an hour or every hour, which will say drink water. So like when I'm working, it happened to me in say summers. So as all our offices, all our classrooms are air conditioned, like in our college also there are certain labs or classroom which are fully air conditioned, and we don't feel like drinking water every time, right? Because the temperature is already regulated. So when you step outside, you might be feeling that like immediately you might not feel to have water, but that will gradually create um, like scarcity, or the water retention in your body will gradually decrease due to that. Okay, so basis on this is one of the example of which I am giving you. So basis on such data, your like you should have an app which will trigger alarm that you have to drink water every half an hour or every hour. So this is one of the example. So now, many people forget to take medicines on time. Suppose if you want to have an antacid before breakfast or before your meal, so you should have that. But we have, we all are busy, we all are professionals, so we might not we are stuck in traffic. By the time we reach college, the time which we should have taken the medicine has gone, and then after you immediately reached rushed to your classroom and you started giving your lectures. So what happened, you skipped that particular medicine, and you skipped that uh, you skipped that crucial point which you should have taken the medicine. So there should be an alarm which will help you, stating that you have to take a medicine. So this is one of the like predictive analysis, and this is recovery why I am considering this in recovery, because whatever medicine you are taking is helping you recover with your any of the disease. It may be a common cough and cold, or it may be any of the thing which for which you are taking the medicine. Okay, so the fourth point is multi-source data decision engine. So I'll give you an example again for the cab thing. So the data which I am, see, if I am booking a cab, I am requesting a cab for source A to source B. There might be drivers which are not uh, following that direction, or which are not going in the direction where I have chosen the destination. So the signal might be circulating across all the cab drivers. Okay, so data which is generated from single source, which is I have requested the ride, so it will be going to multiple source. Okay, and the decision to which what all set of cab drivers it should go is based on like the nearest or the distance, okay, the time, the direction which the cab driver have chosen to go, okay, and the fourth is the amount. Okay, amount may vary from application to application, or to the driver to driver. It may vary because sometimes it will ask you that dynamically price have changed, are you accepting this new fare? Okay, so there might be many parameters which will decide the flow of your request. The similar way, there might be parameters which will be deciding like what treatment or what exact treatment or what exact diagnosis needs to be done, or for example, uh, ambulance, which is the nearest ambulance which needs to be called up. Okay, or for example, if the medicines are concerned, if you are ordering medicines online or if you're ordering medicines in your hospital room, then what like apart from the one which is authorized in hospital, if you're ordering from outside, so which medical person or medical agent will deliver you the medicines faster or at the cheaper rate? Say everyone is giving 10% discount or 15% discount, but some of them are selling it in on MRP, right? So there are multiple sources and multiple data. Like for single set of data, there would be a decision based on multiple sources. So that's what I'm trying to explain over here. That decision engine is one, like decision maker is one, data is for a single data there are multiple data sources, and decision making is done based on like for many of us might know FCFS, let's say first come first serve. There would be round robin, or there would be like the type of request we are like feeding, like based on the system's requirement, like we are choosing round robin or FCFS model, right, which we are normally catering the requests in any of the fashion, right? So last in first out, whatever, like these are the common examples. But decision making, like which one we need to choose, what is our application size, what is our requirement exactly. So the decision making will be done basis on the requirement. So agentic AI will take care of that, not like the one which manually we are doing, right? So that's what agentic AI has been introduced now, and I have given you examples for that. So now this is a flow diagram for uh, this is a generic diagram. This is not specific anything, okay? But I'm giving you a broad level understanding that will help you to understand how the system will flow from your device to the response or response team, or how the devices will get connected. Okay, so there the very first thing you will be able to see here is the sensor. So how the sensor will help you. The sensor is in your device, the watch. The sensor is in the device where the ICU unit are sending the data. Like there is a continuous beep which will trigger every 30 seconds or every 1 minute, that will tell that the heartbeat is on. Okay, there will be a sensor which will give you a beep every say, like for ECG data there would be a certain noise, so it should be moving to and fro, like up and down, up and down. The graph should be continuously rotating. That will help you identify that your heartbeat beats are normal in a certain range, right? So this is the part that sensor is playing. So sensor is sensing the data. Okay. Now, once the data has been sensed, it should be analyzed and it should be fed into the system. So it's not necessary that hospital will be maintaining its own centralized system. So if you want to hire that but if you don't want to own any particular software, if you don't want to maintain it, so you are giving it to any third party. Suppose if I am taking the services from XYZ IT Solutions Private Limited, okay, and this company is monitoring the data which I am giving them to analyze. So they will be having a gateway. Okay, so we have a college, Gyan Ganga Group. The Gyan Ganga Group is having its own gateway or firewall. From that firewall, a secured data will be sent across to the XYZ solution company, and this company will in return analyze and send back the data to you. Okay, so sending will follow this complete cycle, but the gateway present here is the API gateway now. Now, earlier it used to be like, so we have two key role to play here is in gateway there are two uh, main thing, which is NLP and ALP. So NLP stands for network load balancers, and ALP stands for application load balancers. So in this gateway, there will be two key players which are the load balancers. So I am just taking example for one IC room, which is giving me data for 20 patients. Okay, but they for a centralized unit of a company like XYZ Solution Private Limited, there would be multiple customers or there would be multiple rooms from the same hospital which they want to track. Okay, so the incoming traffic from this particular gateway needs to be balanced. So the network load balancer will balance the network level or the data coming from the sensors. Okay, because there is not one single sensor, there are many multiple sensors. So at the same time, if the data is being fed into the system, that needs to be organized. The data needs to be organized. So that organized data will be like the organization or the data, like what we call in database, we have data redundancy, right? So here the data needs to be like transferred, or it should be um, fed in a systematic manner to the gateway. So that part will be taken care by NLP. After NLP, it will be channelized to multiple application load balancers. For example, if it is the data is related to heart rate, it will be sent to the application which will be monitoring the heart rate. For example, if you want to get the data on oxygen levels, so there would be an sub application which will be helping you analyzing the data for oxygen levels or the data from oximeters. So application load balancers are redirecting you to the individual applications or the individual uh, APIs. Okay, so API is the it's basically an agent. It's helping you forwarding or dividing your request to different parts. Okay, so what edge compute is doing is that it is calculating, it is computing, it is analyzing. Okay, so this entire uh, cycle which I explained is the analysis part is done in this edge compute. Okay, edge compute is say computation or the calculation or the analysis of whatever data you are feeding. Next part will be cloud data store. Okay, so cloud data store is whatever data has been fed, the data which is fed to the system and data which has been analyzed by the application or smart AI applications. This is being stored in your cloud data store or the database, simply database, right? From this database, it will be going to the AI layer or the artificial intelligence layer, where you have certain you have set the model, or where you have trained the model. If if this is the range, then act in this. If this is the range, if the oxygen level has dropped below 70 or below 80, then trigger an alarm. Okay, so there comes the alerts. Okay, you have set the field. Okay, now you are for the analyzed data, you are taking the you are triggering the alarms, or you are triggering the alerts, and you are taking the actions. Okay, so for this particular data, say the oxygen level has reached below 70. Okay, so once you get continuous data, say now if it is 620, and for say between 620 to 621, within 60 seconds you are getting 60 inputs that the oxygen level has dropped bit below 70 mark. The alarm should be triggered, or the alert should be triggered to the person which is responsible to take the action, and then the action will be taken. So now see, this is not an automated action here, because we are working on the healthcare domain. If it would be any other application, say if you are saying that my server is full, my server's CPU is running 100%, or my device storage is full, then there can be a script which will help you to do the cleanup activity, or restart your server, or restart your system, right? But this is not the case in for your the treatment or medical facilities. So this is one of the flow which will help you understand the with the example, like for the ICU system. So I have taken one more example, which is a generic example for the smart city. The devices can be from the car, from the truck, or from the patient's mobile, or from the doctor's input, or from the hospital machines. These are now connected with the internet over the like it may be from your optical fiber, or internet over the fiber cables, or from the Wi-Fi, or from the satellite communication channels, or the satellite communications normally normal public is not using. It's only used by government officials or the agencies which are directly connected, like ISRO, or the any other government agencies, right? Now these data, so IoT is all about connected devices, right? If you are connected centrally to one of the application, if you are using any weather app, so weather app will be giving you live data of, like, at 6 a.m. there would be cloudy, or at 12 noon the sun will be at full at its full peak, the temperature would be so and so, right? So IoT is all about connected devices. So these devices, for our example, smart cities will have not only this, like you may have multiple devices which will be giving you the data over the internet, and internet may be over these three particular channels. This will be feeding data to your uh, the computing device, or the server, or the application. Okay, and how you will be giving the data through REST API, MQTT, or COAP, or there may be any other custom mode. So what majorly we are using is APIs, REST APIs. Okay, and this again will be analyzed, computed, and the engines will be analyzing and feeding the data, and it will be storing in database. This is again pushed to application. If you want to view your data, so you have the in your application, mobile application, you are able to see how many steps you have walked today. Okay, or in last 7 days, what was the average steps you have walked in last 7 days. So this is the data which is being pushed into your smart applications, and based on whatever data is being fed, they will be analyzed and presented in form of pie charts, in graph, or any other form which you need to view. Okay, so this is application layer. Application layer, computing layer, and input layer. So I just moved to the next part, which is smart cities and connected health, which we have already covered here, but um, now there needs to be an automated system. So there are algorithms which have been introduced to automate and integrate the devices into the centralized system. Okay, uh, um, integration of healthcare devices by the help of IoT device into the smart city infrastructure. So a smart city infrastructure also includes your roads, includes your signals, it includes your vehicles, or it includes your response teams, okay? And it also includes the amount of the larger group of people which are primarily responsible for the action. Say it may be police, it may be medical team, it may be say army officials, or any other people who are the first responders, or say fire team, like the fire brigade team, which are the primary responders to any of the events. So I just included this slide to make you understand that whatever we data we are feeding, okay, whatever data we are feeding is the primary part. It will play the primary role, it will play primary part in analyzing the data throughout this life cycle. It You may use smart devices, or you may not use data. If it is fed correctly, you will be getting the correct output. So it's not important that device which you are using may be giving you exact accurate data, okay? But to certain extent there is like 91 or 92% uh, possibility are that these data is 91% or 92% accurate. Like what we have, what we say it like this is 24 karat gold, right? Or this is 22 karat gold. So same way, when we consider our data, so there is an accuracy parameter to be considered. And among this three part, algorithm, integration, and then linking, okay? So algorithm may be anything, but algorithm will work on whatever data has been fed to the system, okay? Now, if I talk broadly about Jabalpur smart city initiatives, so there have been various actions taken by the not only the local administrative bodies, but also from the state government and union government to build a smart linking system between the hospitals or between the medical facilities, where they are sharing the data based on availability of beds, based on the current patients admitted on that day, or the current like patients discharged on that day, okay, or the live like the patients which were admitted due to accident or due to critical illness, or like xyz. So entire data is being now integrated, and it is sent on daily basis, okay. Now we'll jump to the next part of our session, which is understanding the agentic AI. And this understanding will help you building your own AI agent in coming future. Okay, so understanding agentic AI, the next leap in intelligence system. As you all know, agentic AI is used to do repetitive tasks. It is not used to generate a new set of data or new set of if for example, if you are transforming any image, or if you are transforming, if you're generating any written content, or if you are generating any of the like say example or a table, or if you're using any of the Microsoft apps and you're using it to generate certain output, so that is not the task of agent. It is random task, or it is subjective task, which is very descriptive and which is very specific to certain output which we are required, which we need, okay. So the task which agentic AI will take care is the repetitive task, which for the like for example, I gave you booking a ticket, okay. So when it comes to monitoring this big setup, so if you say like these range in which Jabalpur smart cities spread across is say 32 kilometers of the range of the city range. Okay, I'm just giving example. Let's say it is 32 kilometer circle, okay, square meters. Then for that particular area, or for that particular circle, there are, I'll give you example, say, one like 1 lakh devices, 1 lakh smart devices which are actively feeding the data. So to manage such a huge number of requests, or such huge number of uh, input, okay, which are feeding you the data, so there must be an agent, there must be a balancer which will help you to regularize, to help you to fasten the data, and it will give you the output in a certain way which you want. So agent will help you doing that. So the conversion around AI has evolved from models that generate content to system that can think, plan, and act. Okay, so the reason I am talking about, say, if I am giving you example, in Jabalpur, if there are 1 lakh users or 1 lakh subscriber for any say Geo or Airtel, okay. So if for all those 1 lakh subscribers or users, uh, it's not possible, or it's not um, uh, correct to say that all of them will be using the system at the same time. So many of them might be sleeping, many of them might not be using the system, many of them might be using actively for certain hours, on or in a certain time range. Okay, so for models, it is important to know, like, what is the peak hour, what is the peak time of usage. Okay, what is the peak time where maximum request will be incoming, or where maximum requests will be sent to the system. Okay, so it will have to think, will have to analyze, okay, and then it will have to plan. So if I take example of cloud, okay, so cloud systems are dynamic, basis on the request, basis on the traffic, the applications scale up and scale down accordingly. Okay, and then they're acting. Okay, this is the action. So when you have peak traffic, the application pods or the application servers will scale up automatically. They will divide the traffic equally, and they will load balance the traffic equally, and then they will again scale down basis on the number of requests, if it is coming down to certain level. So this is what agentic AI is here to help us, based on whatever analytics, based on whatever data which we are feeding it. It will help you enable taking the set of actions which are known. Okay, if there is any new action, if there is any other analytical thought process required at that particular point of time, so it will act, but it will act within the the predicted answers which you have already given to the system. So it will not take any new action. But nowadays what we are giving is, we are also giving the trained data, uh, the whatever output trained data is giving us, we are feeding that same data again back to this system. So it is also analyzing that data, which, like, the answers of that data are also getting analyzed, and the system is getting more smarter. So metadata is getting pushed into the system. Okay, so this is what point one is having. Like, the gist of point one is this. The second thing is, this shift marks the rise of agentic AI, where systems go beyond generating outputs to autonomously plan, act, and complete the task end to end. So what I told you was, Pinkle, I'll just finish this and I'll come to you. Okay. Uh, the shift marks the rise of agentic AI. So agentic AI is now on rise because it will help you doing many of the repetitive tasks. Okay, where system go beyond generating outputs to autonomously plan, act, and complete. So there shouldn't be need of any third party interference, which will ask system to take this action or do this or do that. Okay, so if you are using any chat, if you are using any application, you will be having the chatbot there. So for if you say hi, it will say hi, and it will give you list of options uh, that it can assist you with. Say if you want to reset password, if you want to see what are the say if you are booking a ticket, that you'll have that era chatbot, and it will help you assisting on the set of questions like what we called frequently asked questions or FAQs. So there are chatbots created which will help you in solving the repetitive questions. So that is nothing but the agent or agentic AI which is in place, which is helping the customer care or customer support team to resolve. So they come across like many repetitive calls, and they are answering the same set of questions. So they have set an agent, or they have asked or they have set an chatbot which will help them to utilize that part of time which they would answer to these repetitive calls, and they will use that part of time to enhance or enhance their operational efficiency. Okay. So Pinkle, you were asking some question. I'll take the questions after completing everything. Is it okay, or like if you want, I can answer it. Pinkle raised hands for something. Or may I continue, ma'am? If you ask. Okay, I'll take it in the later part. Uh, Coming to the SRE DevOps alignment, which is my strength or which is my field. So I'm giving you example of all the set of data which considering if I am an application manager, if I am an application owner, or if I am an operational team lead. Okay, so if I want to serve a client which is giving me this kind of data, which is real time, which is dynamic, and which is very critical, and the response to any of the data, it's very critical, and it is immediate action is needed. So for that, mttr should be the lowest as possible, because mttr is mean time to resolve. Mttr means mean time to resolve any problem. So mttr for any critical monitoring system is very important to be low as possible, lowest as possible. Okay, so we need an intelligent alerting mechanism to keep this mttr lowest. So there are service level agreements um, between client and service providers which they agree upon, and based on that they are charging the uh, customers, or the like if I am a service provider, so I will be abiding by the service level agreement with, like, if the criticality is high, if it is priority one, then I need to respond, or I need to bring up the system um, within one, like, half an hour, 30 minutes. And criticality will vary and the severity will vary, and then there will be response time accordingly. So mttr is that. Auto remediation playbooks. uh, Auto remediation playbooks, as I told, there are set of FAQs. You will be having a set of answers for those FAQs, And then there is a playbook. Playbook is like, uh, for every game there are set of rules. So for every question, for every known question, there is a known answer. So they will be remediated, they will be answered by those playbooks or those rules. Okay, rule book. And the third part is observability dashboard, logs, and metrics. So whatever data I'm getting it represented in the form of graph, in the charts, or in the tables. Whatever way I want it to get represented, and I am monitoring that data to take the certain action. So when I talk about SRE perspective or DevOps perspective, uh, if I am enhancing the capabilities of my application to my application code or enhanced functionality, enhanced view, or enhanced UI, okay, I am deploying it, and I am following the entire life cycle, okay, without the downtime of the application, without the without affecting the functionality of application. Application should be running at the same time I have to enhance the capability of the application. So I should have a low downtime. I should have like if I should have inform everyone that the maintenance schedule of my application is so and so, or whatever device or whatever set of people are using my application might face a little difficulty or might face challenges while using the application between this tenure. So all these 3 points inculcates all the life cycle which we need to follow for an application perspective, right? Like maintenance schedule is there. There would be a maintenance schedule. There will be a like deployment schedule, and there will be also like total downtime. Okay, just in case. But now what we have pipelines, and we have like the pods, so we don't need any downtime nowadays. So in runtime only your application is getting a new version. So this is an MTTR comparison before and after using the agentic AI. So earlier, traditional operations team used to have, say, example, this is like I'm just giving you example, okay? So earlier they used to take about 15 to 20 minutes of their time to respond, to analyze, and to bring the application to normal as it was earlier. But with introduction of agentic AI, the application analysis, the data monitoring, and the alert mechanism has become faster, and the action taken has the time taken to like bring back the application to normal has reduced. So it has reduced to almost 40%. So it is now between 5 to 10 minutes. It may be 7 to 7.5 minutes now. So this is as an example, because of introduction of agentic AI, like this mean time for resolution has reduced. And for critical applications like hospital industry, or where the like in production units where the medicines are manufactured, their belts, if there is a issue in the belt, conveyor belts which are used in line of production, so there might be a very big uh, you know um, um, the financial loss for that particular organization or manufacturer. So mean time to resolve is, or it should be the lowest as possible. So agentic AI is helping you there. I'm just quickly, I think we are left with only 13 minutes. So I'll just quickly give you the introduction to the tools which we are using nowadays. So CI/CD pipeline for like infrastructure as a code. The validations are done based on like we are using GitHub or GitLab to push our code through the automation system, or you can use GitHub Copilot, or you can use GitLab, whatever tool you want to use, you can use to push your code. Then the code validation, and then the code will be pushed to an archive. So JFrog or Artifactory, whatever Artifactory tool you want to use, you can use it there. It will again be pushed to pipeline tools. Tools are used to build and deploy the application. So it will CI and CD stands for continuous integration and continuous deployment. So there are Jenkins, there are Electric Flow, CloudBees pipeline, which are certain applications which will help you to deploy the application in runtime, like without giving you the downtime. Okay. Chat GPT, as you all know, it's a very common tool for like you can now everyone is purchasing the LLM or the version which like there is a dictionary or the data dictionary is there, and LLMs are there which they will purchase, and then you can create your own chat GPT bot, or you can create your own version of chat GPT, and you can use it for knowledge management and automation. So you can feed the data, and you can so there are certain restrictions in all the organization that they cannot feed, they cannot expose their data to internet. So they have their own version of chat GPTs. Jenkins and machine learning models are used for predictive pipeline optimization. So if I talk about pipeline is having entire life cycle where you deploy your code. That life cycle needs so that can be covered in a different session altogether. I'm not sure if this part of the slide is like friendly with everyone or not, but these are the broader level and applications of your uh, like automated system which is used for observability. Like the tools which are used for monitoring are like Splunk, there are Isinga, there is Introscope, and there are many other tools like you might have came across Grafana. Okay, so there are many other tools available in the market which we can utilize for viewing and optimizing all our responses. This is an very broad diagram which will help you understand that where we stand. So in AI and machine learning, there are language models, okay, which you can use for knowledge representation, perception, action, data modeling, data model evaluation, model optimization, supervised and unsupervised learning, reinforced learning. Okay, these are the types of um, this is the inner circle. Then comes your RNN, LLMs, okay, convolutional neural networks, transfer learning. Deep neural networks are having these like transformers, okay. Then you have generators. So based on these inner two circles, you can generate the codes for your application. You can generate the speech from like you have text to like speech to text transformation, video generation, image generation, and whatnot, like model generation, okay, tool which are used for engineering purpose or prompting. Okay, that then next come agents, AI agents, which are used for task scheduling, collaboration, okay, coordination and communication, context management, human in the loop oversight. Oversight is where we are standing, is this monitoring part, observability part is what we are standing here. Okay, self reflection, error recovery, whatever action we are taking, autonomous execution, if you are allowing the system to take action on its own. Okay, then comes your agentic AI, which is giving you all the sets. which is self-healing agent. Like if your system is crashed, if your memory has like if you don't have 100% memory left on your system, it will clean up basis on your past cleanup activity. Okay, memory and governance, retention, observability and tracing. So whatever data which we are giving into the logs, it will track that log and give you data. Like suppose if you have a authentication error, so it will give you http 401. Okay, suppose if you have the backend server is not responding, if it may give you 404 or it may give you 503 based on the situation. Okay, so these are the error codes example which the agent will analyze and take action. So agent will only take action if you are allowing it an autonomous execution, because you should give it 100% control, 100% authority to take that action. So this is at the broader level. How to explain anyone about the agentic AI. So agentic AI is above all these three layers, four layers of AI: machine learning, deep neural, and generative AI, and then AI agents. So agentic AI is above all these layers. I'll come to next, which is the foundation for your AI and machine learning. So you must know about supervised reinforcement learning, neural networks, NLPs, okay, and then evolution techniques that will enable systems to learn the patterns, understand language, and make the predictions. I'll shorten up this because we have left time. The time is very less, and I'll jump to the question and answers after that. So this is deep neural network, which is responsible for scaling the intelligence. CNN, RNN, and LLMs, which we have already seen in the diagram. So these are based on pre-training data and models. The way they approach the action is based on the training which we have given or which we have fed the data about. So their ability to handle the unstructured data, it may be text, image, or audio, and it will generalize the data and it will do the task effectively if it gets the structured data. So that part is taken care by like what we see in the Python. We have
Tarun sir, your voice is not audible. Tarun sir, your voice is not audible. Hello. Tarun sir, your voice is not audible. Hello. Now it's okay, sir. No, it's not audible. Tarun sir, आपकी आवाज, your voice is not audible. Sir, you are not audible. Excuse me, sir. Tarun sir, your voice is not audible.
hey, is it audible now?
Yes, yes, it is audible. sir.
Hello.
Sir, you are not audible.
1 minute. My screen was disconnected, so I just reshared, and my mic also enabled now.
Now it's okay.
Okay, thank you. Okay, so I have jumped to a new slide. I was here.
Hello.
I was explaining about the applications of agentic AI. Now, I'll just quickly jump to the demo which I have prepared for the usage of AI, agentic AI. Okay, so I am just explaining you the data. If heart rate, so this is an example for an IC unit where we are monitoring the heart rate, temperature, and blood pressure of any patient, a random patient. Okay, uh, and I have named that it as patient one. Okay, if heart rate is between 120 and 90, and oxygen is less than it's in the range of 120 and 90, so we have to send a red alert that the oxygen level and heart rate has dropped to so and so level. Temperature is feed that what we are feeding is in degrees Celsius. Okay, it's important to like let the system know what are the metrics, if it is unit metrics or it is imperial, whatever metric we are following. Okay, so this is 38.5 degrees Celsius. Upsurge fever warning needs to be triggered. Like if you are using Fahrenheit, so the temperature should be maintained 98.4 or below 98.4. So that is the range of triggering the alarm for that patient is having fever. Blood pressure should be like in the range 150 or 110, the based on male, female, and lower point and higher point. So critical elevated pressure should be triggered like if it is 150 or 110. So ideal is I think 120 is to 80. High blood pressure is too low. So this is the action which agent is taking: notify doctor, push emergency priority, and route to hospital dashboard. So I am just uh, moving it to a demo. Okay. So this is the demo. I have created a Python code which is helping me to analyze a data. This is a dynamic data which is I am having it in form of Excel or CSV format. You may use different formats for your sample data. So I have a data sample data for a say patient one. He is having heart rate. This is the heart rate. This is the timestamp. So if I'm monitoring it for 1 minute, okay, 1 minute is the 12:00 to 12:01. Okay, 12:01 is 1 minute time interval. Temperature he was having is this. Okay, O2 is oxygen parameter 97, 92, 91, 82, 78. BP is blood pressure. Okay, blood sugar, and this is again blood pressure, which needs to be in the low blood pressure and high blood pressure. So this is the parameters which we have given to the system. And remember, this data should be dynamic, because when I'm running a live application, so this data will be continuously increasing, and it will be continuously feeding the data for this timestamp. So it will continuously adding the rows. Okay. So now I'm running the application, which is the agentic AI demo application is the name. Okay. Now this will run, since I am using Windows, so this will be opening a command prompt. And as you can see, if I can maximize this, if it is visible to you, these are the logs which is being pushed to your uh, log directory. Okay, log file to be exact. And now I'm opening it with the notepad file. This is the alert log which I have got generated. So time 12, uh, it was time is between these 1, 2, 3, 4, 5, 6, 7. 7 timestamp are there. And you see this is, there are three levels of logs. One is info level, so information log. One is error log. One is warning log. And this is the critical. So you have set the parameter critical. Okay. So warning is when the heart beat or the oxygen level reached to below 78, or 78 was the data, right? And then you see critical. So after the parameter reached, say, a certain level, so you got the critical warning here. Okay. And now you see the dashboard. If you see the dashboard, you will see this is an HTML. This is just an example demo, so I am not having any like UI. I have not made any kind of UI, like enhanced version of that. This is a basic version just for the purpose of demo. Okay. So this is heart rate, blood pressure, O2 temp. So this is the dashboard which will come onto the TV screen of the person, say nurse or doctor who is monitoring. So instead of that, now they have enhanced the capability to monitor it over the mobile application or the phone. Okay. So this will be the data for any specific patient. Now, if I would have enhanced this application, so I would have name of the bed, I would have name of the patient, I would have name of the hospital, and the last when he was admitted and what is his current condition. So I would have all that data here itself, but just for the sake of demo, I have not included all those stuff. I am just giving you the basic data which we are fetching it from this live Excel sheet. Okay, so this might change dynamically based on your application. So this is the example, the reason and action. Why, what was the reason? Why was the action triggered? Notify doctor, immediate escalate to the queue and route the nearest ambulance. So this is what we are feeding with the action is what we want to take. It will not take any action uh, like in real, but it will just trigger the alarm. It will just notify, since we are in like the live environment, or we are in the we are not taking any action which may affect the person's life. Okay, so it's more about monitoring, it's more about faster response, it's more about sending alarm point. Okay, so this is the small demo for you guys. I'll jump back to this PPT. uh, Ma'am, if we have time, I can take 5 more minutes to complete this. Like one or two more slides are there. Okay. Ma'am, do we have time, or like I can wrap it up?
Hello.
Yes, ma'am.
Yes, sir.
Yeah.
You may continue for 5 minutes. Okay, sir. It's okay.
Okay. Yeah. So,
Good evening, sir. Sir,
I
actually, I am having some doubts, sir.
okay. Yeah, please tell. Please go ahead.
Thanks. Sir, I am Pinkal Jain from Gyan Ganga College of Technology, Jabalpur.
Yes.
Sir, According to me, genetic AI is not suitable or could be risky to use in the sensitive domains like finance or healthcare. So, what
Mhm.
is your opinion, sir?
Yeah, in my opinion also, like I have repetitively said, like we are not using, we are not allowing it to take any action. Like I just gave you examples of agentic AI from the perspective of any application, okay, like which is used to monitor severe or critical data. So we are not allowing it to take any action which may affect person's life, or which may affect any like critical condition. Okay, which may it may help you improvise that. It may help you enabling like faster response. It may help you sending the alarms to the doctor or to the nurse. So we are not actually asking that application to take any action. Okay, so in my opinion also, until and unless these systems are foolproof, the because situations are very dynamic, and which because situations are not like for every patient it may vary, it may not be, it may not follow any kind of rule. It may be very specific to the condition the patient is having. So this is, there are no set of rules which will govern your application. Okay, but for the basic parameter, for basic health monitoring, for the monitoring critical parameters, say blood pressure or oxygen level or any other like heartbeat. Okay, so we can use that, we can enhance our capabilities to send alarm point and trigger it, so that immediately doctors can take any action. So for medical science, there are many other applications, but I am just giving an example. Like I am very like focused on a small example, but there are wide usage of these like agentic AI in medical sciences. So, in my opinion, until and unless you're very sure the system is foolproof and you can rely on the systems, then like we should opt for monitoring purpose. Yes, definitely we should opt these systems for monitoring, but we should be very careful while we use such systems until and unless they are tested or they are foolproof. So that is my opinion.
And sir, what about financial transactions?
Uh, so
Trading
financial transactions are involved. So if you're considering this hospital, or like how are you considering this example, or in general like banking system
in
or
general,
any
sir.
other?
In general, banking system, sir.
Okay, so in banking transactions, the like very few or very less banks have introduced the AI agents for the real-time transaction. They haven't introduced any AI because these are very legacy systems. They don't, if AI has been introduced, if AI has been introduced in 2020, they might be implementing it in 2030 because they want the system to be very foolproof. They want it to be redundant, and they don't want any kind of mess created in any of the financial ecosystem. So because it may create very big like financial loss, or it may create very big financial trouble for any, like if a customer loss is there for any of the bank or any of the financial entity, it's a big loss for entire organization, or entire ecosystem gets affected. So even if I am working in a company which is dealing with the financial, like I am in a fintech, so we are now enabling ourselves to use AI only on, like we are having a certain limit. We are having a line. We don't cross that line to do it on the real time transaction. We are only using for monitoring. We are using it for operational efficiency. We are using it to reduce the downtime. We are using it to enhance the observability capabilities and all other stuff. but not the real-time transaction, because real-time transaction is 1 or 0. Like what we have in our database, it will either get like transferred or it will be reverted back. So that is that those systems are still the same. I can talk about my organization, but I cannot talk about any other organization. So like those systems
Got
are
it, sir.
still
Got
the
it.
same. These are legacy systems. So until and unless these get foolproof, we don't use. So for all the repetitive things, we can do it. Yeah.
Sir,
So
one more question.
yeah.
Sir, in agentic AI, there may be some privacy or security risks or security issues also.
Yes.
Especially
Yes.
agentic AI uses call self APIs.
Yes, yes, yes. So as I told you, like if you are feeding like written data, if you want action driven event to be taken care by agentic AI, you have to give entire authority to the agent. Suppose if you are giving your own credentials, if I talk about IRCTC, you have to feed an entire credential to get your ticket booked. Okay, so that is a risky factor, considering like if you are not using a very trusted version of the agent, or if you're not using any, you cannot even trust Google. It may be sharing your data somewhere, because like considering the
Sir,
safety and security,
Arun sir,
this is
your screen is not moving, sir. Your
yeah,
screen is
yeah.
not moving, sir.
I have just froze it. Yeah,
Okay, sir.
it's in the same slide. Why this matter? I was about to complete this, but
Okay,
we
okay,
took
sir.
like questions. Yeah.
Please, please, sir, please.
Okay. So I'll just move it with this. I'll complete this in 2-3 minutes. Okay. Why does it matter? Because agentic AI isn't just a technical upgrade, it's redefining how we are getting our work done. Okay. So we need to, in all our software development life cycle, we need to understand the goals of our software. We need to plan it. We need to have a action driven approach. We should know the set of actions. We should learn from the results, whatever results which we are getting from the data sets. We have to again feed back into the system. We have to take the feedback. Okay. And from that feedback, again, you have to have new learnings and enhance your capability. Okay. And the last thing is collaborate with humans and other agents. So to the questions which we asked, so there should be a human intervention. There should be uh, like people monitoring the systems which are automated systems which are running now. So there is a paradigm shift. There is still the chance, there's still the scope we can enhance the system's capabilities so that it becomes foolproof. Okay. Uh, I'll skip these slides because we have already discussed it. Uh, this is the um data from for which I have like the data I have used, or the sources from where I have used the data. And last is we have already covered this, but somehow we have already discussed the case study and everything. So I'll only talk about the future vision, which is smart teleconsultation booth, predictive pandemic forecasting, and autonomous hospital operations via agentic AI. So these are the challenges like what we faced in pandemic. So to overcome those challenges, there should be smart like now we are using certain apps like Practo for teleconsultations and other stuff. You should know that India, on an average, India has like nine, like if I say 92 doctors are there for 1,000 people in India. So in US and UK, it is very less. It is say 9 doctors per 1,000 people. So they have very medical facilities. They do have good facilities, but the doctors or the number of doctors which they have is very less. So they rely on this teleconsultation or telephonic appointment. So in India also we do have this teleconsultation approach, but most of you will prefer going in person. So this is one. Predictive pandemic forecasting is one of the thing which like is like in 1970s or in 1900s there were polio, or there were other pandemic spread across. Now in 2000s we had this COVID. So there should be a predictive system which will be forecasting you, say tsunami forecast. Now it's very active across Japan and other like Southeast Asian countries. Okay. And autonomous hospital operations are some of the operations can be done without any fail, like the inventory management, where you have inventory of bottle or the salines or the whatever injections, whatever device, whatever things they are using, whatever medicines they are using. So they have inventory, and they that should be real time. They should inventory manager should know that this is the ask and this is the current stock. So that's it, guys. If anything you want to ask, you may ask. I'll just give you like 2-3 more minutes to think and ask. Meanwhile, I'll just answer like a call. Yeah, someone is asking.
Thank you so much, sir. It is a very informative session and the detailed explanation. I request to Dr. Vimmi Pandey, madam, please conclude the session.
Yeah.
Okay, thank you, Javed sir. On behalf of the Atal FDP and organizing team, I thank to Engineer Tarun Jain, sir, for delivering very informative session on bridging technology and humanity through AI-driven smart healthcare. We sincerely thank you for your time, your valuable insights brought to today's session. Your contribution has been immensely valuable to our FDP. Thank you once again, sir.
Thank you everyone.
Now, within a couple of minutes, we will start the session number 2.
हाँ कर रही हूँ.
Rasool sir, hello. Hello. My voice is audible to everyone?
Hello, am I audible?
Yes, sir. Yes, sir. Now, sir, we will start
Good
the
evening,
session, sir.
sir.
I will introduce, sir.
Okay.
So it's my pleasure to introduce our distinguished resource person for this technical session. This is session number 10, Dr. Akhtar Rasool, sir, and a very good academician, researcher, and the expert in the domain of artificial intelligence, data science, quantum computing, big data analytics, as well as the high performance computing. Dr. Rasool is currently surveying as an associate professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, that is Manet, Bhopal. His journey includes the rich industry experience as a software engineer at Impact Infotech Private Limited. Dr. Rasool
Hello.
has taught a core and emerging subjects such as software engineering, artificial intelligence, data structure, big data technology, quantum computing, and high performing computing. Dr. Rasool has supervised several PhD scholars in the cutting edge area, including the crime pattern prediction, quantum based pattern matching algorithm, missing data imputation, time series, change point declaration, medical image segmentation as well. He has a very impressive publications record, and the various numerous paper is published in SCI, Scopus, Web of Science, IEEE, and the Dr. Rasool is published patent also, a smart agriculture system and the method of integrated with the Internet of Things device. Today we